Alright, so in chapter 12 we are going to look at sequences and series. So we will start with sequences, introduce that, and look at summation notation. So, roughly speaking, a sequence is an infinite list of numbers. So you have infinitely many of them and they can repeat, but they are in a certain order. So the numbers in a sequence are often written as A1, A2, A3, and the dot dot dots means that it goes on. There's infinitely many of them. So A1 is the first term of the sequence, A2 is the second term of the sequence, A3 is the third term of the sequence, and so on. So an example would be the sequence formed by the numbers 5, 10, 15, 20, 25, and so on. So 5 is the first term, 10 is the second term, 15 is the third term, and so on. So we usually write this. We also can write this as, I'm going to put it here, 5, 10, 15, 20, 25, and so on. So if I put it in curly braces, it's understood that it's a sequence with these terms. So we can describe the pattern. So we have to notice a pattern here by writing a formula, or a formula for what we call the general term. So in general, when I look at a term right here, so let's call it an, what would be its formula? How do I get an? So we have to think and notice a pattern. So for the first term, I'm going to think when n equals 1, A1, so A1 when n equals 1 is 5. When n equals 2, notice I have A2, when n equals 2, I have that A2 is 10. And then when n equals 3, it's 15. So A1 is 5, A2 is 10. So if I want to write an in general, what is an going to be? It's going to be 5 times n, because notice when I have A3, for example, A3 is 5 times 3. A4 is 5 times 4. A5 is 5 times 5. So in general, how do I get the nth term in here? It would be 5 times n. So if I wanted A 2020, so there's a term right here that corresponds to 2020 because this sequence goes on to infinity, I would say that it's going to be 5 times 2020. So I can get the value of this term because I know the formula for the general term. So the general term formula is an equals 5n. So we can describe a sequence by saying the formula for the general term or by listing the terms. So for example, another example would be I can have the sequence formed by, so another example, -1, 1, -1, 1, -1, 1, and so forth. So this is a sequence, and it only has two values, -1 or 1. So I just want to keep in mind that the numbers can repeat. All right, so let's look at some examples and get some more intuition about sequences. So find the first 4 terms and the 100 terms of the sequences defined by each of the formula. So for number 1, I have that the general term is described by the formula 2 times n minus 1. So to find the first 4 terms, it means to find A1, find A2, find A3, and then find A4. And then find A100 by plugging in n equals 100. So A1, this corresponds to n equals 1, right? So it's going to be just 2 times n, but n is 1, so 2 times 1 minus 1, so this is just going to be 1. A2, this corresponds to n equals 2, is the second term in the sequence. So this is, according to the formula, this is going to be 2 times n, but n is 2, so 2 times 2 minus 1, so that's 3. A4, this corresponds to n equals 3, so it's going to be 2 times 3 minus 1, which is 5. A3, I'm sorry, and then A4 is 2 times 4 minus 1, which is 8 minus 1, which is 7. So A100 is going to be 2 times 100 minus 1, which is 199. So this sequence can be given by the formula, which is just this, or I can also write it as list the few first terms in the sequence. So 1, 3, 5, 7, and so on. All right, what about the second one? So 2, I have that the sequence, I can call the sequence AN, BN, CN, FN, GN, whatever you want to call it. Fn equals n squared minus 1. So what's B1 going to be? B1 is just going to be 1 squared minus 1, which is 0. B2 is going to be 2 squared minus 1, which is 4 minus 1, 3. B3 is going to be 3 squared minus 1. So that's 9 minus 1, which is 8. And B4 is going to be 4 squared minus 1, which is 16 minus 1, 15. And then B100 is just going to have to be 100 squared minus 1. So this sequence, I can write the sequence by listing 0, 3, 8, and 15, and so on. All right, what about the third sequence, Cn? Cn equals n over n plus 1. So what's C1 going to be? Well, it's going to be 1, so n is 1 now. So 1 over 1 plus 1, which is 1/2. C2 is going to be 2 over 2 plus 1, which is 2/3. C4, 3 is going to be 3 over 3 plus 1, which is 3/4. And then C4 is going to be 4 over 4 plus 1, which is 4/5. And then C100 is going to have to be 100 over 100 per 1 plus 1, because n is 100. All right, and then sequence 4, dn equals -1 to the n plus 1 over n. Notice that in this example, I have that the sign is alternating, so this is called an alternating sequence. So similarly for this one, let's see what d1 is. So d1 is going to be n is 1, so -1 times 1 plus 1 over 1. So -1 to the second power is +1. +1 over 1 is just 1. d2, it's going to be -1. N is 2 now, so it's going to be 2 plus 1 over n is 2, so 2. So -1 to d3 is negative, so -1/2. d3 is going to be -1 to the 3 plus 1 over n, which is 3. So this is going to be 1/3. And then d4 is going to be -1 to the 4 plus 1 over 4. So -1/4. So notice that for this one, the sign alternates. I start with the positive number and then negative, positive, and negative. So this also is an alternating sequence, I'm sorry. And d100 is just going to be -1 to the 100 plus 1 over 100. -1 over 100. So if I want to write this sequence, it will be 1, -1/2, 1/3, -1/4, and so on. So this will be this sequence. All right, so in general, to write a formula for the general term, if I'm given the values for the first few terms, it's going to come down to us seeing a pattern. So in here, we were given the formula and we are asked to find the first few terms. Now we're given the first few terms, we're asked to find the general formula. So for the general formula, you kind of have to get the pattern that happens in here. So for the first sequence, A is 1/2, so A1 is 1/2. A2 is 3/4. A3 is 5/6. So we have to kind of see a pattern. So this corresponds to n equals 1. N equals 1. This corresponds to n equals 2. This corresponds to n equals 3. So I can see something right away for the denominator. So this denominator is 2. This denominator is 4. This denominator is 6. So I can think that 2 is 2 times 1, and then 4 is 2 times 2, and then 6 is 2 times 3. So I can write this as 2 times 1, the denominator for the first term, and then 2 times 2, the denominator for the second one, and then the denominator for the third one is 2 times 3. So notice that 1 represents my n. So in general, my an term should have denominator 2 times n. Alright, because when n equals 1, it was 2 times 1. When n equals 2, it was 2 times 2. When n equals 3, it was 2 times 3, which was 6. And now, to get the numerator, well, notice what's the difference between the denominator and the numerator. This is 4 and this is 3. This is 6 and this is 5. This is 2 and this is 1. So the numerator is 1 less than the denominator. So this is going to be 1 less than the denominator. So 2 times 1 minus 1. 2 times 2 minus 1. 2 times 3 minus 1. So in general, the numerator is going to be the denominator less 1. So this is the general formula for the sequence. So I can write the sequence by listing the terms or by giving the formula for the general term an. What about for b? So our b says that a1 is -2, a2 is 4, a3 is -8, a4 is 16. So the goal is to get the nth term. So find the formula for the nth term. So an, what is the formula for it? So first you have to notice that this is an alternating sequence. So the first term is positive, the second term is negative, the second term is positive, third term is negative, fourth term is positive. So we can take care of the sign first. So the sign is either negative. So how do we take care of the sign? How do we make this negative? Well, I'm going to write it as -1 to the 1 power, because -1 to the 1 power is negative. And then how can I make this a positive? Well, I'm going to do -1 to the 2 power, because -1 squared is positive. And then -1 to the 3rd power, and then -1 to the 4th power. So this ensures that the sign is negative, positive, negative, positive. And then what do I have left? 2, 4, 8, and 16. So when n equals 1, I have 2. When n equals 2, I have 4. When n equals 3, I have 8. When n equals 4, I have 16. So can I rewrite this in terms of powers of 2? Yes, so this is -1 to the 1 times 2 to the 1. This is -1 squared times 2 to the 2. This is -1 cubed times 2 to the 3, because 2 to the 3 is 8. And this is -1 to the 4th times 2 to the 4th, because 2 to the 4th is 16. So now we can see that the general term is going to be, well, look at a3, for example. When n was 3, I had -1 to the 3. So in general, when n is going to be -1 to the n times 2 to the n. So this is the general formula for this sequence. And this is an alternating sequence. It alternates in sign, negative plus, and so on.